we have 3 letters that we can choose from for this. And then what they're asking is, okay, 2 parts. How many 4-letter words can I make with that? And then let's narrow it down to how many of those 4-letter words will have exactly 2 B's in them. Okay, so let's give that a go. When you're thinking about, I've got all these options, and it's kind of like with replacement, right? Again, I like to draw I kind of call them pigeonholes. In fact, what I'm doing right now is kind of, as a general principle, it's called the pigeonhole principle. So I've got things to put into pigeonholes, and I then go through the process of thinking about, well, okay, which pigeonholes do I put things into, and how many options do I have for each of those? Okay, so what we've got is a 4-letter word. Excuse me, and the condition that I have placed on that 4-letter word is that 2 of the letters have to be B's, no more, no fewer. Okay, so if I have to be 2 B's, I then get a choice. Where do I put those B's? Because the B's can be anywhere, right? So in order to work out first, where do I place them? Okay, how many spots can I choose from, right? Well, I've got 4 to choose from, and I've got to choose 2 of them, okay? So that's where I can place the B's. Does that make sense? So it's like, okay, do you want to pick position 1 or position 2 or position 3 or position 4? You pick 2, whichever you like, and then I'm going to put B's in them, okay? So that's how many options I've got. Now, after I've done that, right, there were 4 spots in total, right? And then I've taken 2 of them out of action, right? So subtract 2. So that means 2 remaining spots where I have to choose what letter to go into them, right? Now, let me just go back one step. When I did this, I really should have multiplied by 1, right? Because I picked out those 2 spots, and then I thought, okay, how many choices do I have for what to put in those spots? And the answer is I only have 1 choice because they have to be B's. Okay. Is that right? But now here, for these 2 spots that I have left, right? How many choices do I have to put into those spots? And the answer is 2, right? So this is actually, it should be 2 to the power of 2. Okay. Now you've got to be really clear on what the 2's mean, because they're different, right? Let me just change it. Suppose it was a 5-letter word. Okay. Suppose it was a 5-letter word. And I have 5 spots to begin with. I have taken 2 of them out of action, right? So now I've got 3 remaining spots that need to be filled. Okay. How many letters do I have to choose from to put into those spots?
2.
A or C, so I've got 2 choices, right? So how many options are there? And the answer is, well, there will be 2 cubed, right? Does that make sense? Because I'll do my pigeonholes now, right? I've got 3 spots.
Yeah.
I can put 2 options in here, right? And then 2 in there, and then 2 in there. So it's 2 times 2 times 2, which is 2 cubed. Okay. So this base, it represents how many choices, how many possible things can I put into these holes, right? And then this to the index, or this 3, it represents, well, now how many spots do I have to put those into? Okay. So now I'll say, this is how many places to put the B's. Okay, or how many ways to put the B's. And this is how many ways to choose what should I put in the remaining pigeonholes. Okay, how many ways to fill remaining spots. Okay, so being that I have these other 2 to choose from, if I were to extend the length of the word, as I'm about to do in the next part, right, what's going to change is this power up here. Right? It was 2 in this case, it'd be 3. Generally speaking, it's going to be
n minus 2.
Yeah, n minus 2, because I start with however many letters, and then I take 2 out of action, right? So 4 minus 2 gives us the 2, or 5 minus 2 gives us the 3, and so on. So that's my general case. So now I just put the B's and the non-B's together as options. So my total number of ways to get two B's is that times this. So there's my sum for now. Okay. Let's move on to the next part. Given the same conditions, so n's a positive integer that's a multiple of 2, an even positive integer. Okay, so I've got the same conditions, so you can actually see as well, like, this is a big clue that not only am I going to have to use this part that I've just worked out, I'm going to have to use this part because it's got the same conditions applied to it, right? So whenever you see the conditions match up, you're like, okay, I'm going to need to use this part and this part together. Okay. As it happens, we don't get to this right to the very end, but we still need it eventually. Show that if this is the case, then the number of words of n letters, right? Okay, I'm going to rub off some stuff. There's my answer. Oops, I shouldn't have got rid of that. Okay, so n letter words. And what conditions are applied to them? With 0 or an even number of B's. With 0, 2, 4, 6, and so on. B's. So that's a lot more options. They've gone, number 1, they've changed it from 4 letters to n letters, right? And then they've changed this from just that single case 2 to a whole bunch more cases. Okay, so that's what makes this really hard. You remember how we talked before about how when a problem is listable and manageable, you can see the logic of what's going on, and then you apply to a general case, and that's when it gets harder. And then they say, well, here's the result. That number should be this. You're like, where on earth does that come from? Okay. So let's tackle it one step at a time. Let's come back to this. Right? So this is the total ways for there to be 2 B's in a 4-letter word. Right? So now let's, as we were starting to do before, let's generalize this thing. Okay? If it was not a 4-letter word but an n-letter word, okay, what things are going to change? And the answer is, well, clearly that form will change, because this was, I had 4 spots to fill before, and I want to choose 2 of them. So now I'm actually choosing from n spots. Okay? And as we noticed before, this part here came from how many other alphabet choices I had. That's still the same. And this part comes from, now how many places do I have to put those other non-B letters? And the answer is n minus 2. Okay. Now from here, the great thing about this is we've generalized once, so now I can go to the other cases, you see? So if I were to go up, right, to say, well, what if I have, actually, because of the way I've laid it out, I'll go this way. If I go down and say, what if I have no B's? That's this first case here. That's pretty important to establish, right? So to have 0 B's, and it's an n-letter word, right? It's like, well, look, first I have to choose how many places will have B's in them, right? I have n pigeonholes to choose from, and I don't want any of them, right? So that's how many spots for B's. And then I have to place the rest of them, right? So that'll be 2 to the power of n minus 0, right? Which is 2 to the n. And you think about this, and you're like, of course this makes sense, because this means that I have A or C, A or C, A or C, n times. And this, of course, is just 1 to the n. It works so far. Whenever you generalize, you test it out with a case to make sure it works, and then you keep going. So that was going down to 0 B's. If I go up to 4 B's, okay, what changes? Again, it's still n choose. But I'm like, okay, now I want to reserve 4 of these pigeonholes to have B's in them, right? And then I have to fill the rest of them. I've got 2 options to fill for the rest of them. How many pigeonholes are left after I've knocked out 4? And the answer is n minus 4. Okay, so now you can see this is starting to form a pattern. Okay, it's starting to form some sigma notation, right? That's where it's going to go. Okay, so if I add this all up, I'll leave that on the board, even though I should be going down, but I've got space here, so I'm just going to write it there. Okay. Do it in a different color to indicate that. Oh wait, I should have done one more thing. Dot, 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 dot. This doesn't actually go forever, does it? There's actually an endpoint, right? Which is, what if all of them are B's? Okay, so they're all B's. Okay, well, I'm going to, out of my n pigeonholes, I will reserve all of them to be B's, right? Now, I have two options to fill some of the pigeonholes in, but how many pigeonholes are left? And the answer is none. And you're like, oh, of course, because this is one, and this is one. There is only one way to put all B's in the letters, okay? Right, so that's better. Now I have the whole series here, okay? So this is my total. I'm just using that to say the sum, okay? It's going to be this plus this plus this plus this and so on, right? So it'll be n choose naught, 2 to the n, n choose 2, 2 to the n minus 2, n choose 4, 2 to the n minus 4, dot dot dot, because it'll be 6 next. And then where I'm going to end is this case here, n choose n. Okay, so far so good?